Hi, everybody. Thanks so much for coming. I am feeling a tiny bit nervous because the keynote was so amazing, but I'm hoping I can carry on the good vibes that he had in it. Speaking of good vibes, thank you to Burnt Toast Creative who let me use their illustrations in my talk. At the very least, it will look nice, but hopefully it'll be informative as well. So my name is Mandy Michael. I'm a Google developer expert in web technologies. I'm a Microsoft regional director. That sounds very fancy, but it's just part of the MVP program. I currently work as a staff software engineer at Higher Up Australia, which is a disability support services provider that's based here in Sydney. And most importantly, this is my dog Jello. And this is important because I use his name in my code samples, and when I don't explain that it's a dog, it can be a little confusing. So I am referring to a dog and not to the tasty snack. I'm also on many of the social networks, Twitter, X, whatever, Mastodon, Blue Sky. I am on Threads, but nobody's on Threads, so I'd put LinkedIn there instead. So if you want to contact me, any of these, they're at the bottom of all of my slides, so you can tweet me, whatever it is on the other ones, I don't know. So my talk is called Advanced HTML for Good Developers. And now that I have successfully attracted a room full of good developers, what it's actually about is HTML for performance and accessibility. And what I'm going to do is run through a little bit about why HTML is important. I will demonstrate why it's important for accessibility and performance and the impacts that it has. And then I'll briefly discuss some tips that you can follow to improve your HTML. And then for the last half of the talk, we'll focus specifically on how HTML can improve the performance of your websites and applications. Now, I know that there's a lot that we do as developers, engineers, whatever these days. And things like performance and accessibility are often left to the end. But this is the worst time to start with these things. You're making it a lot more difficult for yourself. So the purposes of today is to introduce you to some ways in which you can start addressing accessibility and performance straight from the HTML, which is typically the foundation of everything that we're building. So when I refer to accessibility, I'm referring to the practice of making websites accessible, making your websites and applications usable by as many people as possible. Now, typically, and most importantly, this refers to making things usable for people with disabilities using assistive technology like screen readers. But in practice, it also benefits people using unusual or old technologies, so internet connections, or if you've got a temporary impairment like migraines, broken arms, that kind of thing. So it's a lot more than, people often assume. In the same vein, web performance, it is a measurement and it is about ensuring that what we're building can be accessed quickly and efficiently on as many devices and internet connections to reach as many people as possible. This can include things like speeds, perceived performance, smoothness, interactivity, as well as, actual load times. And the easiest and most low-hanging fruit way to deal with accessibility and performance is with HTML, which I will be upfront. I know I call this advanced HTML, but HTML is very simple. It's a very forgiving and friendly language. But just because it's simple, often we make the mistake of assuming that it's also not valuable. And what I'm hoping is by the end of today, I can dispel that way of thinking, even if it's just like a little thought that you have that maybe you'll be like, oh, actually, HTML is really handy. So we're going to talk about HTML. Whenever we start building a website, typically we'll chuck some HTML in a page, right? And then the browser is going to interpret it, but it doesn't just take it as is. It actually ends up as a big long string of text, which the browser then has to parse. And then it goes through that big long string of text and it starts creating the parent and child relationships. It'll do this until we have something that you're used to seeing when you inspect the page in the browser, which is the DOM tree, otherwise known as the document object model. And we use that to manipulate, edit, and move things around on the page. Now, there are a few other things that it'll do, layout, compositing, but they're not important for today. What is important is the DOM tree, because this is constructed of what we provide the browser. If we request a div, it's just going to give us a div, right? So we're going to talk about TypeScript, which I know is very weird for a talk about HTML, but trust me, I know that when you say trust me, it immediately makes you not want to trust me, but let's just go with it. So who here is familiar with TypeScript or any kind of type language? If you just raise your hand. Cool. So a lot of people. For those that aren't familiar, TypeScript is a typed JavaScript language. It does everything JavaScript can do, but a few extra things. And what you can do with it is you can assign a type to your data, and then TypeScript will check that at compile time. And if the value and the type don't match, it's going to throw an error. You might have something like this. We have an interface of dog with some stuff on it, and then we assign a type that matches the relevant information, whether it's a string, a number, or Boolean. We pick something that makes sense. And if we're using TypeScript correctly, we're being explicit about what the shape of our data should be. It makes debugging, writing, reading, and working with our code a lot easier. And at the end, it results in a much better output. This is essentially what we do when we write our HTML. We specify if it's a heading, what kind of heading it should be. If it's a list, a link, a paragraph, bold, italic, dates. There's a whole suite of elements we can choose from to best represent our content. We're just assigning a type to the content using HTML. And we do this for similar reasons that we use TypeScript, to define the shape of our content to make it easier to read, write, and work with. And in TypeScript, we have the concept of an any type. And that just means that it can be anything. But if everything is typed as any, you're going to lose the benefits of the language. And this is the same in HTML if you use divs everywhere. You lose the benefits of the language. Because of this, it's really important that we actively choose what types our content are. Because if you choose a generic element, you're going to get generic output. It's the same with TypeScript, same with HTML. For example, this is a very simple page about dogs. I will add a side note. There is a little bit of dog propaganda in this talk. So I apologize if you're not into dogs, but my dog is very cute. So here we have a really simple page. Very, very simple. It's all divs. Even the links at the top are divs with an on-click event. It's just a big block of text, and it's okay. You can sort of figure it out. But if we compare that to a page with more meaningful HTML, you can immediately see that this is better, objectively speaking. There's a structure, there's a hierarchy. It's more readable, more practical, and more useful just by picking the correct type for our content. And yeah, you could replicate this with CSS, but the thing that people often forget is that HTML actually has a lot of functional benefits that CSS will not provide, because CSS is just cosmetic in these cases. So not only would it be more work for you, but it's hugely problematic for assistive technology and other technology that rely on HTML in order to consume the page. Because not everyone and everything interacts with your page the same way. There are many technologies that try to read your HTML and rely on us using it correctly in order for it to make sense. So, for example, Google search bots rely on HTML to determine the content hierarchy on your page. So if you don't do that properly, you'll find that your SEO is impacted. Reading apps like Safari's reading mode relies on HTML in order to restyle the page in a way that makes sense within their restrictive view. Text-to-speech tools like Alexa and Siri, and of course, assistive technology like screen readers. They all rely on us using it correctly. And one of the ways that the browser does this for assistive tech is using the accessibility tree. Now, much like the browser creates the DOM, it also takes the DOM and it modifies it to form something that's useful to assistive technology, and that's called the accessibility tree. It uses the native semantics of HTML to create an interface for reading and navigating the page. For example, a screen reader is able to interpret the accessibility tree and reproduce it as speech. Now, browsers like Chrome and Firefox have accessibility tree inspectors. This one is from Firefox. And because it's based off what we provide the DOM, if we just provide divs, all you really get is a bunch of sections and text leaves. So it's not very good, it's not very useful. If we compare that to the page with more meaningful HTML, there's a lot more information here in the accessibility tree. It says it's a heading, if it's a paragraph, a block quote, a landmark, a separator. It's more detailed and it has a more useful structure. So a really good way to demonstrate this is to listen to what a screen reader sounds like. We're not going to go through the whole page, but I'll just use it for demonstration purposes. So first we'll start with the div page. This is where my propaganda begins, by the way.
Home. Good dogs. Bad dog myths. Dogs, they are good. We are dedicated to educating the world on why dogs are good and how they can make your life good. By Mandy Michael, August 3, Road 2018. Why are dogs good? Dogs are loyal, intelligent, devoted, and affectionate. They are known to improve our physical and mental health. Michelangelo, also known as Jello. /screen %20 shop.
Okay, I'm not going to make you listen to this, the image file name. That's because I took a screenshot from Instagram, didn't rename the file, and didn't add an alt attribute, so it's going to read out that awful file name that I had. Now, aside from the terrible image, you might have also noticed it didn't tell us that there were any links, and that's because as far as the accessibility tree is concerned, despite the on-click event, it doesn't see it as a link, it sees it as a piece of text. So you kind of have to figure it out based on what the link says, like home might be okay, but maybe bad dog myths you won't pick up. It also said road instead of third for the date. And for a very simple page, I feel like that's enough not great experience to make this quite difficult for a user of assistive technology to navigate. Comparing this to a page with more meaningful HTML.
Navigation main navigation 1 item. List 3 items. Visited. Link. Home. Link. Good dogs. Link. Bad dog myths. Heading level 1. Dogs. They are good. We are dedicated to educating the world on why dogs are good and how they can make your life good. Mandy Michael. August 3rd, 2018. Heading level 2. Why are dogs good? Dogs are loyal, intelligent, devoted, and affectionate. They are known to improve our physical and mental health. A dog named Michelangelo, also known as Jello. Image. The group.
Okay. Much better. It read out the links. It told us how many there were. It said that I'd visited one. It got the headings right. The date was correct. The image was better. Overall, again, for a very simple page, we got significantly more context and information. By selecting our HTML more meaningfully and putting a bit of effort in, we're actually doing a lot of heavy lifting for the user because instead of them trying to figure out what a link is, we've told them. In the case of the screen reader specifically, there's so much more information for it to read out to the user as they're navigating the page. The end result being a much more page for users. And it's not just the accessibility that benefits from a more considered approach to HTML. Because overlooking HTML can lead to a very large and messy DOM. And a large DOM will impact your load times and your performance. It has a measurable impact and increases the data load for your users. So it costs them more. Because users and scripts, as they navigate the page, the DOM has to recompute the layout as they do things and interact, including the position and the styling of all of the nodes. This can significantly slow down all of your load times. As a result, a large DOM, particularly in conjunction with complicated CSS, can severely affect the rendering and the runtime performance of your websites and applications. So Google's Lighthouse Performance tool, if you've ever used it before, recommends less than 1,500 nodes, max depth of 32 nodes, and no parent with more than 60 child nodes. Now, I want to be really clear here. This is the absolute max that you want to be at. If you're anywhere near this, this is really too much. I mean, it's going to warn at 800, which is 1,500 is nearly double that. So you want to be way on the other end of this. But more complex pages and applications can mistakenly very easily hit these numbers, particularly these days when we start building at a component level, because you add a div here and a div there and a component wrapper and all of these things, it's easy to forget they all add up and have to go on a single page. And if you're using JavaScript frameworks, which we often are, you have to remember that JavaScript have to manage all of these nodes as well, so it matters even more. So what you want to do is make sure that you're only creating nodes when you need them and destroy them when you don't need them. Don't fill your page up with things that isn't necessary. It's just going to contribute to poor performance. And because the accessibility tree is based off the DOM tree, any impacts to the DOM tree for your performance are going to further impact the accessibility tree. This is Eric Bailey. He's an inclusive design advocate. really amazing, great stuff if you're interested in accessibility and performance. And he says that when the accessibility tree is slowed down by excessive code, it can create a lack of synchronization between the current state of the page and what is being reported by assistive tech. This results in a mismatch between what the user is presented with and what is actually on the page, which I'm sure you can imagine is really confusing. If you think of it, it's kind of having bad lag in a video game or really bad dubbing when you're watching K-dramas or anime, or they're just things that I like. But, bad dubbing, awful. Also, if it is really bad, a large complicated accessibility tree and a large complicated DOM can actually crash the browser. So that would mean that any users of your assistive technology can't actually use your website or application. And this is, you might think, doesn't apply to you, but just like the keynote said, we want to make things usable for as many people as possible and be as inclusive as possible. But also, many of us are using and building products for people of core services like banking apps, healthcare, government. If people can't access what you're building, it's not a good product. At the end of the day, everything that we put into our page adds up and can have an impact on your performance and accessibility. Every div, every link, every button is going to contribute to that. So we shouldn't just throw things in willy-nilly. We need to dedicate some time to how we choose our HTML. So this was a really long-winded way of me saying, don't just use divs. I'm not saying don't ever use them, but don't only use divs. Instead, use the named element for what you're building. If you have a header, use a header element. Footer, nav, article, label, button. There's a whole suite you can choose from. HTML is intentionally simple. They're named to help you out. I can assure you it is not a trap. It is here to guide you. Now, I'm the first to admit it's not always that straightforward. Sometimes you don't know what to choose, but this is a really good starting point because HTML is, as I say, designed to help you out. It will improve the accessibility tree at a bare minimum, but in some cases, it can also reduce the size of your DOM. And that is simply because you're being more considered in what you're putting in the page. Because unfortunately, when we just chuck divs everywhere, that is often just a symptom of a lack of care and results in that large, complicated DOM. So similar to using the named element, headings are numbered for a reason. Use them in the correct order. This is because headings provide a clear structure and hierarchy for the page. And when you use them out of order, you're actually messing with that hierarchy. So for example, as I mentioned earlier, Google search box actually relies specifically on headings to determine content hierarchy. So if you're not using them, it makes it a lot harder and your SEO will suffer. Additionally, users of assistive technology rely on headings in order to navigate the page. So they can do that in a number of ways, typically through some kind of tooling. This specifically is the rotor, which is part of like the VoiceOver that you're using. This is VoiceOver for Mac. And what it does is it groups bits of information from the page, like headings, links, marks, and it kind of acts like a table of contents. So they can click through this and jump to a section on the page that's relevant to them, like, for example, scripting. So rather than relying on our eyes to look through the page, users of assistive tech will often use tooling to find what they want without having to listen to the whole thing. So much like we have awesome tooling for things like accessibility, the other thing that we can do with HTML is make the most of the built-in functionality. And I would suggest that you should favour using native functionality over creating your own. This is because, again, it's better for accessibility, typically, not always, but typically. It tends to work better across mobile devices, plus it's a lot less work for you, right? Why build something that already exists? We don't need to reinvent the wheel. Some examples, details, looks like an accordion, right in HTML, data list, it's like a drop-down menu, type of date. I'm sure you've all seen the wonderful date picker in HTML. This one I will caveat that Just because it's a date doesn't mean you need a date picker. Date pickers are great for discoverable dates, like appointments. If you're asking me to input my date of birth, I can assure you I do not need to click back the many years that it would require me to reach that. So use a text box because I know what it is. I can type it in and move on. There's a great article actually called Maybe You Don't Need a Date Picker by Adrian Roselli. It's in my resources at the end. You should absolutely read it. It's very, very good. He goes through all this with much more finesse than me. The other thing with these kinds of things you'll probably come across is that designers don't like them because you can't style it and it doesn't match the designs. So at this point, I'm going to tell you, just because it's in a design does not mean you have to do it. I'm not saying be a jerk about it, but there's always room for compromise, especially if it's going to result in more functional and accessible improvements. You should never be afraid to discuss potential changes to a page if it's going to improve the performance and the accessibility. I've never been in a situation where I've said to a designer, hey, if I make this small design change, it's going to significantly reduce the amount of code I have to write and it's going to work better for accessibility. And they've gone, no, I'm not doing that. Designers are pretty reasonable. Just have the conversation. Compromise is always possible. That said, there are also features that have very good styling with CSS. Dialogue is one of them. Modal, pop-up, overlay, whatever you want to call it. This is the one where it disables the content below. Similar is the popover, which you're probably thinking that is exactly the same as what you just showed, but there is a difference. The popover, the page is still interactive, so it's more like toast notifications. I don't know what else you call them other than a toast. Content pickers, teaching UI, those kinds of things. This is actually sort of newish, so browser support isn't fully there. It's everything except for Firefox, but it is in nightly at the moment. So I believe it's going to, I was reading Interop 2024 and apparently all the browsers are going to support this year. So we can start using that soon, at least by the end of the year. Another really good example of something that comes with a lot of functionality is the button. Very common, lots of useful features. Unfortunately, typically these days, and the last time that I had to work on some code at work, I had to fix this. People were typically writing divs for buttons with an on-click event. There's a handful of reasons for this, but like I've mentioned, just use a button. And the reason for this is because buttons have lots of features, as you can see from the green ticks, which the div does not have, all the red ticks, which is bad. Buttons, focusable keyboard interaction, announced to assistive tech, reported to the accessibility tree, is giving you a lot of free stuff. And if you want to recreate this with that div, you have to write this HTML, you have to add all of this, all these attributes. You have to write at minimum this JavaScript. This isn't all of it. You need more for touch devices and that kind of thing. You also need to test it, debug it. So much more work. Why? Don't make it hard for yourself. Make use of what HTML is offering you. Now, the argument that I've often had from people is that divs don't have any styling attached, whereas buttons do, and it's annoying to fix the styling of the button. I get that. Be it button CSS reset by Andy Bell, copy paste, CSS, looks like a div. You don't have all that problem anymore. Much better than having to test, write more code, debug, reproduce all of the features that HTML would have given you. And the same applies to anchors or links. Lots of free stuff. So make sure you use them. Now, Jess, who's speaking on Friday, her talk is making single-page applications accessible. She goes into this in a bit more detail, so I highly recommend you check that out. Basically, when you use HTML and make use of the functionality, it's like using a pre-installed JavaScript library that's already tested for you, already debugged, it's already working. It's one less NPM package you have to install, and that's great. because that's less JavaScript, which means our bundle sizes are smaller, which improves the performance of our websites and applications. So make the most of built-in functionality, not just with elements, but with attributes as well. So we talked a little bit about the date element, date attribute. There are a lot of really useful features that come with HTML attributes. The ARIA attributes are a really good example of this. They are a collection of attributes that are specifically for accessibility. And they aim to fill the gaps in standard HTML to give more context to the accessibility tree that we talked about earlier. Examples: ARIA pressed, selected, expanded, grabbed, do what you might expect. They indicate that those relevant actions have occurred on an element. ARIA live indicates that an element is going to be updated. This is great for shopping carts or status updates. ARIA hidden hides elements from the accessibility tree. And ARIA labeled by identifies an element that a label applies to. You'll see this a lot in forms, for example. There is a whole heap of them, and they're useful for a lot of things. But instead of going through them all, I'm going to give you a bit of a quote from my friend Julie. Julie is an internationally renowned accessibility expert, so you can trust what she says. And it says, if you're writing CSS that conveys information, ask yourself, is that information also in the accessibility tree? If not, a bit of ARIA might help. These are particularly useful for complex interactions that you'll often find in applications like drag and drop, for example. And if you're not sure if you need it, you can use the accessibility tree that I showed you earlier to inspect and see what information is available. Okay, so I did say the last half of the talk would be about performance. So that's what we're going to talk about now. As much as I would love to keep talking about accessibility, we're going to focus specifically on optimization, loading, and performance of our websites and applications just using HTML. And we're going to start with images. Typically, images take up more bandwidth than any other resource, and they tend to be one of the biggest impacts on our performance. Now, there's a lot of things you can do to improve image performance, optimize your images, use modern image formats, but there are also some simple HTML approaches you can take as well. Now, this next bit I almost didn't include because I called it advanced HTML and I wanted to include things that you might not be that familiar with, but it's such low-hanging fruit and it's so easy to do and it has such a big impact. So I added it back. I took it out and I added it back in. Add a width and height to your images because this, and I have to prepare to say this word, helps to improve the cumulative layout shift. Cumulative. It's a really hard word for me to say. I'm going to call it CLS. The CLS is a performance metric. You might see it come up in the Lighthouse Performance tool, and it measures how much elements shift on a page as content is being downloaded. And the reason that this is important is because typically there's a delay between the HTML and images being downloaded, and this can cause any content below an image to be pushed down the page. This shift in layout can be really disruptive to a user. I'm sure you've been there as you're reading the content on the page and it shifts down, really noticeable on mobile because of the smaller screen real estate. So we want to make sure that this doesn't happen because if there are a lot of images in your page, this can significantly increase the work of the browser as it's got to recalculate the layout and positioning of all of the nodes every single time an image is loaded in. So by adding a width and height, you're essentially reserving the space, the image can load in, and there's no more layout shift. Of course, with the introduction of responsive images, a bit more of a problem because if you say an image is 1,000 pixels wide and you load it on a mobile, it's going to look like crap. With that, we have the source set attribute, which allows you to specify a comma-separated list of images, file names, along with a width or density descriptor. Density descriptor just refers to the DPI of an image. We'll use width as an example. So in this case, we're saying we have an image here, Jello 1000, that is 1,000 pixels wide. What this does is tell the browser that the image is 1,000 pixels wide, so it doesn't need to download it to know how big it is. People often assume that the 1000W refers to the screen viewport size. That is not the case. It is the width of the image in pixel units. If you want to specify images based on the viewport, you need to use sizes attribute in conjunction with source set, where you can specify any kind of media condition similar to what we use in CSS. And that will indicate what size image you want available based on that media condition. So for example, in this case, we're saying at a min width of 1000 pixels, I want a 1000 pixel wide image, which means that it will pick from the source set the Jello 1000 image. If there isn't one that matches, it will pick the first image that's bigger than the size you've requested. If you want to change the dimensions, like you want a portrait image on mobile and a landscape image on desktop, you can use the source element inside the picture element. And what that will do is allow you to specify completely different sized images, do a bit of art direction as they call it. You can have it zoomed in, whatever. This, again, works exactly the same as media queries in CSS. Now, there are some other things you can do, like with aspect ratio in CSS, but that deviates from HTML, so we won't talk about it. If you want to talk about that, we can talk about it afterwards. I'll be around. Also, Anton, who is doing a talk on CSS tomorrow, it's not actually in that talk, but I know that he's talked about it before, so you can also talk to him about it. And the last thing I want to talk about with images is lazy loading. With a sneaky picture of my dog. Now, lazy loading essentially defers the loading of images until it reaches a particular distance from the viewport. It looks something like this. So you can see in the network pane on the left there, as we scroll, an image is being loaded in rather than loading it all at the beginning of when the page loads. Previously, we would handle this with something like the intersection observer or event handlers like scroll and resize, but we don't need to do that anymore because HTML for some time has had native lazy loading built right into the browser. And all you need to do is add the loading attribute with a value of lazy, and that's it. It figures everything out for you. Very, very simple. The default value is eager, and it's like not including it at all. But the reason that I mention it is because a lot of image libraries, Next, for example, their image component, or I believe the WordPress image management does it as well, they'll add loading lazy by default, which is great because most of your images you're going to want to lazy load. The problem is that we only want to lazy load images that are not in the viewport, because if an image is in view when the page loads, it's considered part of the largest contentful paint metric, which is the render time of the largest image or text block that's visible in the viewport when the page first starts loading. And if you try and lazy load an image that's not in the viewport, that is in the viewport when the page first starts loading, it's going to load in slower, so it'll have a negative impact on that performance metric because it's not going to be ready when the page first starts loading. So only when they're not in the viewport. So if you're using Next, for example, you want to make sure you've reset that for those images so that you're not negatively impacting the page. Browser support's really great. It's been around for a while. I think it's just IE that doesn't support it. If you're still supporting that, I'm very sorry. That is a bad time. There are polyfills though. So now we're going to finish up by talking about optimizing loading and prioritization. And to do this, I'm going to very briefly basically talk about how the browser prioritizes resources. And I say very basically because it's actually quite a complicated process, and that would be a whole talk in itself to go into it in detail. So very quickly, in HTTP 1, browsers would typically open multiple TCP connections and it would load one resource at a time. So prioritization of resources was based on whatever resources were requested first. However, in HTTP 2 and HTTP 3, this was changed to a single connection and you could instead make multiple requests at the same time. But that doesn't mean that every request can be fully responded to at the same time. And that's because a connection is limited in how much data it can send. So this is particularly true at the start of a connection, as we can only send a limited amount of data for each network round trip. And therefore, the server needs to choose which requests it needs to respond to first. As a result, the order of this prioritization can have a really big impact on your web performance, because as it prioritizes one thing, it's going to deprioritize another. So if you send the JavaScript first, your images will be deprioritized and vice versa. This makes a really big difference for any render blocking, JavaScript, CSS that you have, because they have to be downloaded in full before they can be applied and executed. Furthermore, each browser does it differently. It's not the same. There's a really great post by Robin Marks called HTTP3 Prioritization Demystified. It's in my resources. It's very, very good. Goes into this in a lot of detail. But essentially, he talks a lot about how the different browsers prioritize different resources. And depending on how you have things set up, you might see noticeable differences between like Chrome and Firefox on the performance of your websites and applications. So, you know, what are we supposed to do about browsers doing whatever they want? Well, actually, we can use fetch priority for this. It is a HTML attribute, and it allows you to specify the priority of resources like CSS, fonts, scripts, and images. And it allows you to change that default priority from browsers, but it also gives us the opportunity to create that more consistent behavior across browsers. It has 3 values. High means you want to prioritize it, low means you want to deprioritize it, and auto means browser can do whatever it wants. Unfortunately, prioritization is a tad more complicated than 3 values, so it's not going to give us the fine-grained control that we want. Also, people often assume that if you set it to high, it's going to set it to the highest priority, and if you set it to low, it's going to set it to the lowest priority. But that's not actually the case. What it actually does is set a relative priority in relation to the browser's prioritization rules. So it's just going to raise or lower the priority by a set amount. It's more like a suggestion to the browser than an explicit rule. For example, this is an example from web.dev, so it's Chrome-based. A style sheet has the highest priority. So if we set a fetch priority of high, it's just going to be the highest priority still. If we set it to low, instead of being the highest priority, it will be downgraded to a high priority. In neither of these scenarios have we explicitly set a high priority or a low priority. It's just raised or lowered the amount accordingly. As another example, if we have an image that has a low priority, if we set the fetch priority to high, it will actually set it to high, which is great. If we set it to low, it's just going to retain that low priority. So this is why understanding how each browser prioritizes resources can have a really big impact on the performance, because while you might think it's not worth setting low priority here, for Chrome, that may be true, but in another browser, it actually might change the priority to create that more consistent behavior across browsers. So it's handy to know how browsers are doing things in order to best apply these attributes. A really good place that you can use fetch priority is in image carousels, which marketing teams love, especially at the top of a page, affecting that largest contentful paint metric. Essentially, what you can do is set a fetch priority of high to the main active image, and then set all the others to low, and that will prioritize the first image, meaning it'll download quicker, meaning it will improve the largest contentful paint metric. And then the other ones will load in once that one has been received and downloaded. So, you know, this is going to improve performance just by making a slight change. So if you think about other places that you might be able to apply this, particularly in that largest contentful paint area, you'll find that things get a bit snappier. Browser support is pretty good. Chrome, Safari, Edge, not Firefox. I do know that they are implementing it at the moment, so hopefully we'll have that in soon. It is also on Chrome for Android, iOS, Safari, and the Android browser, so you can use it. And one of the benefits of HTML is it'll just ignore it if the browser doesn't know what to do, so you don't have to worry about fallbacks or polyfills or anything. It'll just use it for the other browsers, worry about Firefox later. So the next thing I want to talk about is resource hints. Now, requesting a resource from the server can take a very long time. So if you can handle this ahead of time, it can make your websites and applications feel a lot faster. And this is where resource hints come in. So there are 2 options under resource hints at the moment, and that's pre-connect and DNS prefetch, which you can use as a value of the rel attribute, which also has a lot of useful features. You should totally look into that. We're going to look at pre-connect first. So essentially, what pre-connect does is it informs the browser that your page intends to establish a connection to another domain, and you want that to happen as quickly as possible. You can speed up the load times by about 100 to 500 milliseconds, according to web.dev. I'd be very surprised if you sped it up by 500 milliseconds. If you manage to do that, that is like such a win. Woo, it's probably going to be more like 100. But by establishing the early connections, you can speed this up quite a bit. You'll find this really handy for image CDNs or streaming media if you're doing a lot of streaming media. However, if you are making a lot of connections to third-party domains, pre-connecting all of them is going to be counterproductive, right? If everything is important, nothing is important. So it's best to keep pre-connect for only critical connections. For everything else, you can use DNS prefetch. That's going to save time on the first step, which is the DNS lookup. That usually takes about 20 to 120 milliseconds. That might not seem like a lot, but everything adds up. If you can save 100 milliseconds 5 times, that's going to make a big impact to your performance. DNS prefetch has really good browser support. In Firefox, it's not supported on HTTPS at the moment, and it's not supported in iOS, Safari, and the Android browser. But again, the browsers just ignore it if they don't recognize it in HTML, so it's not going to hurt to use it for the other browsers. So finally, we're going to talk about preloading resources, which is probably the one that most people are familiar with. This is the most common HTML attribute for performance on the web. Now, you can preload resources by adding the rel attribute with a value of preload to a link element in the head of your HTML document. And this is going to cache the resource so that it's available immediately when it's needed. What preload does is help prepare resources that you don't need right now, but you're going to need later. So like pre-connect, we only want to use it on critical resources. We want to rely on the browser and the other attributes I just mentioned or values for everything else. Unfortunately, people mistakenly use this incorrectly all of the time. This tweet from Zach Leatherman made me chuckle. People put in preload on everything, and you don't want to do that. It's bad. It will negatively impact your page performance, right? If you use it in the wrong places, if you use it on the wrong things, it's actually going to do the opposite. And I didn't really know how to explain this in a good way, except in response to this tweet, Robin Marks, who I mentioned earlier, had this awesome tweet, which we're going to use because it's perfect. And again, I don't like reinventing the wheel, so thank you, Robin. What we have here is a couple of examples of how resources are downloaded. And the top one is without preload, bottom is with preload. And at the top, we have HTML at the beginning. I don't know if you can see that in purple. And then the next one in like a yellow color is the bundle.js, and then we have an image. And at the top, the image is requested. It's deferred until after the render blocking JavaScript is completed. So downloads takes like 2.25 seconds, which is kind of a long time. If you're lucky with HTTP 1, the image can be requested alongside the render blocking JavaScript. It'll download much quicker than if you've used preload, so it'll finish in 1.75 seconds, milliseconds. Oh, no, seconds. However, this is typically not what happens, unfortunately. What's more likely to happen is this bottom one, where your JavaScript and your image or any kind of resources are going to fight over priority and bandwidth. As a result, it's going to impact the download of your critical resources like your JavaScript. In some cases, the image might actually download before your JavaScript has finished downloading. This results in a really bad experience. That's when you start getting all of that jank on the page as things like load out of order. So it's really important that you test this stuff and you use it in the right places. Some places that preload is very useful. We can use preload for assets that aren't loaded directly by the HTML but are critical to the experience of the page. So resources inside CSS like fonts or images, preloading chunks of critical JavaScript bundles, resources that JavaScript requests like JSON, imported scripts, or web workers, or large files. If you've got a really large file, you can start preloading that so that it's ready quicker on the page when the user gets to that area. That said, again, I want to remind you, and using an analogy from Harry Roberts, where he said, preload is like a queue jump. He's English, so that's why it says baller, but you know. It's like a queue jump, right? If you jump the queue, you get in quicker, but it also means everyone else behind you gets in a little slower. So don't overuse it. Don't add it on everything. Add it to the most important things on your page and rely on things like DNS prefetch and stuff like that for everything else. Because otherwise, you'll probably find that what you've done is actually made things worse than if you didn't use them at all. Just before I talk about this next bit, Harry Roberts has a really great talk, which is also in my links, called Get Your Head Straight, which I highly recommend you check out. It's all about how you can improve the head of your websites and applications to improve performance. It's very, very good. So I wanted to add this sneaky little bonus in. It's not HTML. It's actually a HTTP status code called 103 early hints. What it does is define interactions between the client and the server, and you can utilize everything I've just talked about: DNS prefetch, preconnect, preload, fetch priority. And for example, it can allow the browser to preconnect to sites to start preloading resources even before the server has prepared and sent the final response. And this is great, right? Because if you tend to land more in this realm, you can learn about preconnect, DNS prefetch, all of that, and you could also apply it in the HTML. And in some cases, preload in particular might actually be better with early hints than using it in HTML or vice versa with some of the other properties. So very handy thing to do. I love transferable knowledge. This is an example from MDN. It looks a bit like this. You can see it's got rel preconnect in here. It's a good thing to experiment with to see which one is going to benefit your performance better, whether you do it in early hints or with HTML. Browser support is okay. It's pretty good, actually. Major browsers all support it, except for preload, unfortunately. It's currently not supported in Safari, and in Firefox, it sits behind a flag. But again, from what I understand, it is being worked on. I don't exactly know when it will be completed, but hopefully we'll have full support for this soon. And then that's a good place to start experimenting if you don't usually sit in a HTML realm. So I just want to say, I love this slide. This is my favorite, so I actually put it in quite a few times. When it comes to performance, the features that I've demonstrated, very useful. But it's not going to do anything if you have 20 megabyte images and like a bazillion megabytes of JavaScript. So use it in conjunction with optimizing your resources, and that's how you'll start to gain these benefits. If we make the most out of our HTML elements and attributes to improve things like our performance and our accessibility, and we stick to some of the simple guides that I mentioned, utilize the built-in functionality, we can take big strides in making our websites more useful and usable, not just for performance and accessibility, but for our users and any kind of different technologies as well. I mean, who knows? Maybe AI will start reading our HTML and inferring context from that as well. And we're doing this all by using a technology that is already in our websites, just using it like a bit better. And I'm not even saying you need to learn all of HTML, like just a little bit better will make a big difference. If you use HTML to its full potential from the beginning, you're making things easier for yourself, for other developers, but not just now, but in the future as well, because new technologies rely on spec in order to figure out how to read things. So what I'm hoping is that the next time you're working on a component, an application, a page, a project, you make the most out of what HTML has to provide and you dedicate like a little bit of time to choosing the right elements, making the most out of the features and attributes, because there's so much that you can gain from using HTML more meaningfully, using HTML to its full potential, and there's literally nothing to lose, except for maybe with preload. But aside from that, nothing. HTML is very forgiving. If you mess it up, it's not going to have that huge an impact, but you can have a big benefit from using it correctly. So thanks very much. I hope you got something out of my talk. If you want to talk to me about anything, come see me afterwards. Resources are up on GitHub. Thank you.